Capacitors, AC and DC, some people will refer to them as caps. Capacitors used in DC circuits will have a polarization marker on them. These should not be used in AC circuits as they could explode. Capacitors come in voltage ratings and capacitance ratings called microfarads. The easiest way to describe a microfarad is its storage capacity and reactance to changing voltages. I like to say a capacitor is an electrical shock absorber. It helps smooth out voltage changes. When replacing a capacitor, you should try to get an exact match. If not, use the 10% plus or minus rule in microfarads. When it comes to voltage, you can use one of a higher rated voltage, but never a lower. You will see capacitors in many shapes, sizes, and many different materials. I won't go into the exact construction, but they function similar to batteries. They will store the applied charge. In AC circuits, remember back when I talked about your meter reading RMS, and when we apply AC voltage, we see 120 volts, but the actual peak voltage is 170 volts. Your capacitor will capture the entire 170 volts and give you a boost for starting motors. This is why on start windings of capacitor start motors, you will get a voltage reading higher than your incoming voltage reading. Let's talk about what's going on. First, no current ever passes through a capacitor. Some programs will tell you it does. They are wrong. If current does pass through, you have a bad capacitor. When current starts to flow, the negative electrons start to build up on one side of the capacitor. That buildup causes the other side to expel electrons. When AC current changes polarity, the electrons start to build up on the opposite side, pushing the electrons off the side they were on. There is also a natural flow of electrons from the capacitor plates during the mid-cycle of an alternating current. When the voltage level of the capacitor plates is higher than the cycle, the electrons flow to the lower voltage. This all happens so fast you cannot see it. The effect, though, is it looks like current is passing through because your capacitor fluctuates with the frequency of the alternating current. Some do actually call capacitors pass-through filters. Again, this is not actually happening. They are stabilizing the voltage changes in the electrical current and in some cases giving you a higher voltage output for a short period of time. To test a capacitor, take it out of the circuit and use your meter set on microfarads. Always discharge a capacitor before putting your hands on the terminals. You can do this by placing a screwdriver across the terminals. Be careful, sometimes it will put off a large spark. Test across the terminals and you should be within 10% of that rating. If you are within 10%, your capacitor is good. Here are some pictures of failed capacitors.